Hello everyone. Today I'm going to present our recent work on real-time relightable Gaussian splatting using hybrid path tracing. Relighting and composition of Gaussian splatting are important. Gaussian splatting cannot be used as an asset to build complex scenes because it cannot be relit, and inter-object effects such as shadows and inter-reflections cannot be simulated, which limits its applications in many fields. Moreover, it is also challenging. Conventional photorealistic rendering techniques such as Monte Carlo path tracing cannot be directly employed on 3D. Existing relighting methods for Gaussian splatting typically adopt either approximate rendering formulations or rely on Gaussian ray tracing, yielding poor relighting performance and low rendering efficiency. In this work, we borrow the idea of hybrid path tracing. And this is the overview of our method. We employ a three-stage process. In the first stage, we reconstruct scene geometry using planar-based Gaussian splatting for G-buffer generation and extract the underlying mesh. In the second stage, we leverage physically based differentiable rendering to recover mesh material properties and the environment map. In the final stage, we use FIPT to refine material properties of each Gaussian and take into account visibility and indirect illumination by ray tracing the underlying mesh. The qualitative comparisons on two datasets demonstrate that our method can produce realistic relighting results. Compared with the baselines, our method achieves more accurate specular reflections. The quantitative comparison demonstrates that our method has the best relighting performance on synthetic 4 relight dataset, and also outperforms all baselines on tensor synthetic dataset in terms of PSNR. Additionally, the SSIM scores of relighting are also comparable to the best. The PSNR scores of novel view synthesis on synthetic 4 relight dataset and albedo on tensor synthetic dataset are also the best. We show the relighting and composition results on scenes from MIP NERF 360. Our method can produce more realistic results due to plausible shadows and indirect illumination. This is a demo video of Gaussian splatting real-time relighting and composition. Here is the timing breakdown of our real-time relighting and composition in these scenes. All timings are averaged over 100 frames. Finally, we discuss the limitations of our method: limited geometry reconstruction accuracy, inherent inconsistency between Gaussian splatting and the extracted mesh, limited accuracy of material decomposition, and FIPT only supports fixed environment map settings. Thank you all for listening.